More than 250 experts in the traffic signals industry joined together in person to hear a range of papers here in Nottingham. These recordings are brought to you by AGD Systems, Colas, SRL Traffic Systems, Smart Video and Sensing, Vivacity and Unex Traffic.
Thank you Margaret, and thank you JCT. 30 years in ITS, and this is my first JCT symposium, so I've definitely got one thing wrong, haven't I? I should make more effort, and I promise to do that in the future. Yeah, so we're going to give you another GLOSA presentation, but it's hopefully a little bit different. Firstly, in where it's set, we were looking at GLOSA on off-slips, signalised off-slips, and also secondly, in what we were trying to achieve. We were trying to see if there were some real benefits in operating GLOSA, particularly in terms of measuring emissions from the tailpipe. So yeah, that's what we're going to do. We're going to do it in two parts. I'm going to do the first part, which is very much an overview of the solution. I'm not going to give a lot of technical detail because I really want to concentrate on the results, the emissions benefit that we saw. So I'm going to run through mine fairly quickly and then hand over to John, who will give some information on the findings from the portable emissions testing, the tailpipe emissions testing we did when running GLOSA on and off slip. So, briefly then, Highways England project, or I suppose I should say National Highways project, funded as part of the Air Quality and Digital Roads programme that was run from September 2019. Because of COVID, ended up running to March 2021. So it's a completed project with a full set of results. A lot of help from TFGM, who seem to be doing a lot of this sort of stuff. Basically, we were doing the project in off-slips in the Manchester area, so we were hooking into the Manchester UTC system. Our GLOSA app is developed by a partner of ours, East Point, so they were a key player in this as well. Where do we do it? Very briefly, we were looking for off-slips that were slightly differently configured, so at least one uphill off-slip and one downhill off-slip. So we were running this on slips in, I think the downhill off-slip was in Bury on the M66 and the uphill off-slip in Oldham on the A627M. I put this slide in, but I don't think I need to really explain what GLOSA is to this audience. So I think I'll skip over this, but very, very briefly, I think there's some good points earlier about how do you deliver GLOSA effectively in vehicle. And our solution is to use an app because it's a test app, but there are a number of health and safety issues associated with that, and it took us a lot of effort to get through the health and safety process of Highways England for them to let us run an app basically on a windscreen mounted device. If you want to deliver this for real, I think you've got to think about different ways of doing that, and we're already running a trial, as you can see in the bottom right, with integrating GLOSA information into Android Auto infotainment display approach. Okay, I was going to say a little bit about the architecture. The project is much bigger than just the emissions monitoring, so there's quite a lot of infrastructure deployed for the project we were running. But I'm just going to say a couple of things, points of note. At the bottom, the way we get the traffic signal timing information that we need to generate GLOSA messages is effectively directly from the UTC server, from Scoot information that's provided by the UTC server. So there is no infrastructure deployed at all to actually get the GLOSA information, nothing at the traffic signal site, and also nothing to deliver to the app, because that's done by the mobile phone network, very similar to the York approach, actually. The other thing to say is we try to do it using an open standard approach. So we deliver spat and map using the CROC standard that was defined by DFT a few years ago. That's effectively based on ITS G5 spat and map messages. Okay, so yet another GLOSA app. This is just a quick view of our app. I'm not going to, again, dwell on it too long, but it's got a number of areas. The main area is a representation of a signal head that provides the arrival prediction, the state of prediction. there's a target speed, and then there's really some engineering information to help us when we're running tests. So the current phase, how long it's going to be in that phase, how far a vehicle is from the junction, the current speed, and the junction location. So we were planning 3 phases of testing to try and understand the benefits of GLOSA. The main phase of testing was this portable emissions-based testing, measuring tailpipe emissions directly for several freight vehicles, because the focus was on freight, and trying to minimise stop-starts on inclined off-slips of freight vehicles. We had a couple of other phases as well. One, just some very general ad hoc testing from the team and a wider cohort that was really looking at, as a sort of almost a minor point, how effective is a GLOSA app, how do users feel about it. But then also we were hoping to do some more formal testing with a freight cohort. Unfortunately, I was impacted by COVID and we never actually got to do that. Anyway, I think I'll show you a full run-through of the GLOSA app in operation on and off slip, just so you can see what the sort of testing runs were like.
Maintain speed near 64 miles per hour. Maintain speed near 54 miles per hour. Maintain speed near 46 miles per hour. Maintain speed near 40 miles per hour. Maintain speed near 40 miles per hour. Green for 9 seconds.
So I wanted to show you that just so you had a sense of sort of what the testing involved and a sort of a full run through of GLOSA on and off slip just to see how it works basically. So on to test results. I'm going to skip over these. Basically, like I said, we did some qualitative analysis of basically driver experience of using the app. And effectively what we found actually is over time and more use, people got used to it and actually found it more effective and actually gave us more positive feedback. If you want to know more, feel free to speak to me afterwards, but I'm not going to dwell too long on it. Okay, so to the really important results, the really important findings of John's work, the highlights, what we found for freight vehicles using this slip, the effects of GLOSA, up to a 27% average reduction in CO2 emissions. Similarly, up to 17% average reduction in NOx emissions. So on average, that's 4 milligrams per run reduction in NOx, 252 grams per run CO2. That equates to 12.5 pence per run per vehicle saving in fuel. And also, what we found was some measurable reduction in dwell times on slips. There's some stuff on the right that's more detail about the different effects of uphill and downhill and the different vehicles, but that's detail, and I'm going to hand over to John now so he can give you more of that, and yeah.
Thanks, Paul. So what I will do is I'll talk you through a little bit about the colour scheme just to start with. So when you see any figures from me, you'll see that the GLOSA on data is shown in green and the GLOSA off data is shown in blue. And these particular charts, there are two ways that we have shown the data. And in fact, this is not the most common one, and you'll see another one on the next slide. But essentially, this is just the run through the slip lane. So the number, and we've just ranked the NOx emissions and the CO2 emissions in order. So what you can see is that for CO2 in particular, and this was the heavy-duty engine on the uphill slip road, that there is this very obvious, if you like, on a percentile basis, positive impact of GLOSA on the amount of CO2 that's emitted. And CO2 is a surrogate for fuel economy. So if we look at the data from the PEMS, here is the alternative. Sorry, to just talk a little bit about the background. So essentially, we've got two vehicles that we're looking at. So we've got a heavy-duty Class M1 truck with 20 tons loading, so an HGV, and then we've got a light commercial vehicle, which was actually a VW Caddy. Now, both of those applications are fitted with particle filters, but they have very different methods of NOx control. So a light commercial vehicle, it just has exhaust gas recirculation. Exhaust gas recirculation is where you take burned exhaust and recirculate it back into the air intake. This reduces the oxygen in the chamber, and this means that you produce less NOx when you go through combustion. But the NOx is moderated dependent on the load on the engine. So the smoother the operation of the vehicle, the less NOx you produce, and the more efficiently the EGR system works. And then similarly, on the heavy-duty truck, we have what's called selective catalytic reduction. So on this application, on this emissions control system, you inject urea into the exhaust. It undergoes a thermolysis process. So effectively, it splits down and produces ammonia. Ammonia then reacts across a catalyst with the exhaust. So again, you can see that if the engine is constantly changing and you dose urea in proportion to the NOx that's coming out of the engine, if you smooth out the engine operation, you make it easier for the NOx control to be optimized. So if you like, one of the most unexpected things from GLOSA was that it was causing the driver to drive in a very smooth way. And you can see that from Paul's video. And so the smoothness of the drive was having a positive effect on both NOx emissions and on CO2 emissions. And of course, with the analytical equipment that we had, we were able to kind of quantify that as into the numbers that Paul was talking about. And we used a portable emissions measurement system. So, you know, I'm sure everybody's aware of Dieselgate. And so post-Dieselgate, the legislative framework in Europe has moved to the road rather than the lab. And PEMS systems are what are now used for certifying vehicles. So we have got the best possible measurements from the GLOSA testing in order to validate the performance. So what we have here are results from the light commercial vehicle. Apologies to people on the other side of the auditorium. But essentially what I've done is I've divided the data here into percentiles. So this is 0 to 20, 21 to 40, 41 to 60, 61 to 80, 81 to 100. And we show on this chart, on all the slides, the top left is average speed, the middle is the slip time, so the transit time through the slip lane. And at the bottom we have CO2 on the left, NOx in the middle, and NO2 on the right. And so what we can see here is that there's a significant benefit in terms of higher speed with GLOSA operating on the light commercial vehicle on the downhill slip, which obviously means less time in the slip. And then we're looking at absolute emissions here, and you can see that right the way across the board, we're seeing lower CO2, and we are seeing lower NOx. So if we switch to the light commercial vehicle at Oldham, which is the uphill slip, now we can see that there's significantly less impact on the speed, and it's only when the slip time is the longest, when it's most congested, that we see benefits in terms of CO2 and in terms of NOx. And this is the smoothing effect. So essentially, even when it's congested, GLOSA is making people drive in a way that reduces fuel and it reduces NOx emissions. So a kind of double positive. So now we're looking at the heavy-duty truck. So this is the Berry truck. And what you can find here in the heavy-duty data is that there doesn't seem to be very much effect at all on speed or the time in the slip lane. What we do see here in the kind of the faster runs through the faster runs through the slip lane is that there is a CO2 benefit, but it's much more difficult to pick up a NOx benefit. And the main reason for it being so difficult to pick up a NOx benefit is because on a Euro 6 truck with all the different after-treatment systems that are employed, there's hardly any NOx. And so the noise of the measurement makes it very difficult to discriminate anything. However, you've got a lot more CO2, and so the chances of being able to pick out the benefits are greater. And so now here we have the HGV at Oldham. So this is on the uphill slip lane. Again, we're not picking up anything really in terms of the vehicle's speed and the dwell time in the slip lane. However, again, when it gets congested, there's a very significant advantage. And there's small advantages here in terms of CO2. But when it's congested, when the driver is progressing in a very even way up the slip lane, we see these benefits in terms of CO2, which are really significant, and these benefits in terms of NOx. We're tending to see the NOx benefits outside of the peak driving. So when it's a bit easier to drive smoothly. But I think the main message here is that there is a quantifiable CO2 benefit. There is an apparent NOx benefit, and it's related to the way that the driver is allowing the after-treatment systems on the vehicle and the optimized combustion. So the steadier the engine runs, the higher the fuel efficiency. So those two things are coming as a consequence of the driver's behavior. So I suspect I've covered most of those aspects here, but as I say, I think the point is that we've only looked at the light commercial vehicle on a Euro 5 basis, so that's quite old technology, and then we've looked at the heavy-duty truck of the best possible technology, and there are vehicles in between. So I think if there are gaps that need to be filled, if we need to understand more, then we need to look at those gaps of vehicle technologies, and I would expect that they will have so a Euro 6 passenger car, Euro 6 diesel passenger car, may well have a really significant benefit, and a Euro 5 truck will have a much bigger NOx benefit than we see from the Euro 6 truck. So I think to understand and quantify the benefits, maybe a little bit more testing is advisable. And then I'll hand back to Paul.
Thank you very much. Just for a quick summary, I suppose I should have said, actually, both of these off-slips, unusually for national highways junctions, we're running Scoot, which means that's one of the reasons why we could run it here. And it works very effectively with the way that we do it. It's also possible to deploy GLOSA with minimal infrastructure. I think we've proven that. And there is, as we've said, a measurable positive impact on emissions. And generally, we got positive driver feedback. Put a few next steps there. I think it's been mentioned a few times today, but GLOSA remover is challenging. Highways England are actively, National Highways are actively looking at how that can be improved, as are a number of other people, I know. So I think it's looking hopeful that you will be able to do some sort of GLOSA, maybe not all the time with junctions running mover, but time will tell on that. There are, again, as lots of people have said, there are also lots of other issues still around GLOSA as a live, wide-scale deployment solution. Things like driver safer, driver behaviour, understanding the impact on things like Scoot when you've got lots of people using GLOSA. So there are still lots of issues to investigate. And then there's some of the other emissions ones that are quite important. We think it's worth doing some emissions testing on a range of other vehicles, given the results here. In particular, Euro 6 passenger cars, diesels, and also Euro 5 trucks. So I think they're the main next steps. Yeah, I think that's it. Any questions?
Thanks very much indeed. Any questions from the floor? Over on the right here.
Thank you. So very interesting. You said about the risk assessments and health and safety. I presume, what did you make of the potential, as you showed it, of telling HGVs to slow down while still on the main line and then potentially actually advocating a higher approach speed at the stop line in terms of risk?
Well, one thing we found with HGV drivers and HGV companies in particular is that they're sort of very focused on driver safety and smooth driving anyway. So you're sort of almost talking to a converted audience. So that's the first point. And then secondly, because they are HGVs, there isn't that massive speed differential that you get. And then generally they are slowing down anyway on the slip. It's just that you can give them better advice about when to slow down to smooth out their drive, basically.
So there's not a massive difference, it's just giving them confidence at the speed that they can approach.
Exactly, yeah. It's not a massive difference, but it makes a big difference, as far as we can tell.
Okay, thank you.
Any other questions? Certainly, I would like to know whether you would have several runs with the same driver. Did you manage to show any difference with the driving over time? So if they did 12 runs, did you show any improvement as they got used to it?
I mean,
emissions.
We looked at the data from the perspective of 5 days a week and 3 periods through the day, and literally some of those. So I think the heavy duty vehicle, we had at least 100 runs, GLOSA on and GLOSA off, and there's no trend of learning.
Okay.
I think the driver, the kind of the steer that the driver is getting to drive more smoothly. As Paul said, heavy duty drivers in particular are they're hard drilled for fuel economy, but this even makes them more smooth.
Yes, so it is a win-win, really.
Yeah, worth noting, we were trying to minimise the number of unknowns, so it was the same driver for the whole week of testing. Yeah.
Okay. Any other questions? At the front here.
James Dowling from Bristol City Council. Really interesting to see the app working live. That's the first time I've seen it in that presentation, so to visualise how it works. And the data looks really interesting and positive in terms of the emissions in particular. But how does the commentary for your app link in with perhaps commentary of the sat-nav? Because the two might cancel each other out, or one might override the other, and then might be an issue there.
And that is indeed, that's one of the challenges we have of how do you do this sort of in-vehicle technology effectively with the other things that are going on in a vehicle. It's the same with things like in-vehicle signage, because, if GLOSA operates at a junction when you're likely to be giving direction information. So there's going to have to be a way going forwards of integrating these technologies to make sure that you don't confuse the driver.
Thank you.
Okay, I think any other questions may be taken after this session ends. I want to say don't apologise by saying not saying National Highways, because I've only just got used to Highways England after Highways Agency, so to have to change again is, it'll be another 10 years. So thanks very much for your presentation.